First, I want to thank the organizing committee, especially Dr. Yahya, for giving me this opportunity to be part of your prestigious conference. I hope that after the lunch break, everybody's awake. This is really a sort of interactive session, and let's start with it. Special thanks also to Dr. Faris, who long time back, he was teaching me this graphics, and there is a lot of things to add on. Let's start. So, first of all, okay? Yeah. Yeah. So just my outlines for this lecture is I'll go first some basics about the neonatal ventilation, which already we discussed during the workshop, but just touch on it. So as an introduction to my lecture, then I'll go through the graphics, the waves and loops, how it looks like. Then I will go to the interaction between the patient and the machine. So starting by the importance of the graphics. So why we need the graphics? Before we were just putting the patient on the ventilator and checking the blood gas, the X-ray, and we don't know what's going on. But with the graphics, you know that what's going interactive between the ventilation and the lungs. And this will help us a lot. Why? Because we can properly know the ventilator function, and we can wean. We can fine tune to decrease the work of breath and maximize the patient comfort. We can optimize ventilation. We can, by the graphics, check the response to therapy. We can pick up problems as secretions, leak. And very important is the disease process, the respiratory disease process. So we are talking about lung compliance problem or airway resistance. So I want to give you an example here. So the compliance, when we are talking about compliance, we are talking about the lung compliance. And when we are talking about resistance, we are talking about the airway. The best example for that is if I take a balloon. So if I have an old balloon and a new balloon, so the old balloon is a stiff lung. A new balloon is a stiff lung. So, and an old balloon is a normal compliant lung. So so if I want to inflate a new balloon, I need to generate a lot of pressure to create some volume to inflate it. So this means that I have a problem with the compliance. So I'm talking about compliance here. Now, if the other way around, if the neck of the balloon is narrow, so there is high resistance, so this is the airway. So the more airway, narrowing of the airway, there is an obstruction in the airway, the more resistance is there. So the best example here about the lung compliance when you are talking about respiratory distress syndrome, and the best example of the airway resistance is meconium aspiration syndrome. Okay, now why the graphics again is important. So when you want to adjust the ventilation, there are 5 things we need to look for. We need to look for the patient, chest rise, ET tube level, air entry, secretions. So this is something you need even to ask the nurse about. The second point, you need to look for the vitals, trends, histograms. Also, of course, blood gas and chest X-ray. And the 5th element for me is the ventilation. So you need to go back and check your ventilator. You need to see what you have set, and please look for your measures. What the machine is actually giving to the patient. Okay? Also, from the ventilator, it will show you that there is some leak. Of course, you need to look for the graphics, waves and loops. This is which we are going to discuss. The resistance, the compliance, the peaking if there is hyperinflation, and of course if there is any problem with the the tubings and the sensor. Just this is a basic graph about the ventilator. So how it works? So you have simply there is air coming, the medical air with the gas, with the oxygen. It is blended. Okay, it's going to the reservoir, how much FiO2 you want. Then it will come to the ventilator. There is the tubings here. So the ventilator job here, the most important thing here to understand that the major function of the ventilator is to compress this air. So it's to create a pressure in the ventilation circuit. Then it will go to the humidifier, and from the ET tube, it will go to the patient. So this is very basic understanding, which is very crucial. And here we put nearby the baby is the flow sensor. It will check what is the flow of air going in and out, and accordingly, it will calculate your what? Tidal volume. Thank you. So then the air, there is a valve here. So when the inspiration is initiated, the valve will close. So the ventilator will pressurize the air. So the pressure in the tubings is higher than the patient, so the air will flow in this direction. When the inspiratory cycle finished, the valve will open, so the pressure is lost. The pressure will go down, so the air will go from the higher pressure to the low pressure. It will, expiration will happen. So this is just a basic understanding. So other things, so for the ventilation cycle, how it works. So there is a trigger. So the machine to start the inspiration, there should be a trigger. Is it machine? So it is fully controlled. So you should set it and the machine will start it by itself, or the machine is waiting for the patient to trigger. So this is called assisted. So this is the first point, the trigger. Now the machine needs a limit or a target. You put the machine to ask, you ask the machine to do something. What is it? I want to reach certain pressure or certain volume. So this is our target. And with this, there is a rising time over how long I want this target. Then for the inspiration to complete, there is a stop. There is a cycling. There is a time I want to stop the inspiration. So this is the third point, is when the expiratory valve will open. This can be either time cycled or flow cycle, which will be only in one option, which is in pressure support ventilation. So this is again the types of breathe. Is it assisted or it is controlled? So this is just how it looked like in the ventilator. Now we mentioned about the cycling. So this is the time the expiratory valve will open. So usually we are depending in most of the ventilator modes on the inspiratory time. So the in assisted control, in SIMV, or in continuous mandatory ventilation, all of those modes depend on the I time. So this is time cycle. So when the time finished, the expiratory valve will open. The other option is the flow cycling. The flow cycling, it's a way to ask the baby, the patient himself, to determine his inspiratory time. So it's a more physiologic, we assume that, more physiologic that the patient himself will determine his inspiration when it will end. So, of course, this is depend mainly on the lung dynamics. So the flow cycling, in other words, so the flow when it's coming up in inspiration, we ask the ventilator to stop to the inspiration at certain point. So when it is coming in this direction, so let's say I want it at 30%, 25%, 15. So most of the ventilators nowadays, it's automatically set at 15, 20. So you need to know where your ventilation, at which level it's stopping. There are other machines that you can play with this. How it helps you, I will come to it later on. So if it is a flow cycling very late or it is very early, we'll come back to it. Another concept, very, very, very important, is the eye time. Now, we know before that we need to keep eye time for a preterm infant, let's say 0.3, 0.25, 0.35. Okay, on which way we are determining this? So actually, to reach your eye time, you need 3 to 5 time constant to reach your eye time. And the time constant depend on what? The time constant depend on the compliance and the resistance. So just to understand it. So if you have high resistance, so there are secretions in the tubings, there will be definitely need for more eye time. Or let us say a preterm baby, you give him surfactant, compliance improved. So again, initially in the RDS, the baby will breathe shortly, small breaths. But later on, when you give him the surfactant, the lung opens up, the compliance improves. So at that time, this means that he will need more eye time. So this is a simple way to understand what is the required eye time for the baby. Now we will know from the graphics how it looked like to adjust it. Now after this simple basic, we will come to the actual topic, the waves and the loops. So the waves is you are talking about parameters compared to time. So either pressure, flow, or volume. But in the loops, you are differentiating between two different parameters, either pressure to the volume or flow to the volume. So the waveforms, we have 3 waveforms. As we said, it is related to the time. So the pressure wave, usually it starts from peak. So there is a peak pressure, let's say 5 or 6, whatever you depend. So it will continue till the initiation happened. So this is the time the pressure will start to go up till it reach the target. Then it needs to stay in the plateau till the inspiratory time or the stop of the ventilation happens. So the expiration will happen to come back to the peak. So this is the pressure time waveform. Then the flow, it will start by 0. The flow, it will go up fast because you need to reach a certain pressure. So it will start fast. Then when the pressure starts to be in the plateau phase, the flow will go down slowly till at the time that you stop the breath. So it will cut down and it will go to the negative. So this negative means expiration. So it will come again to 0. Then it will start from, it goes fast, the air will go out fast. Then it will slowly, as the lung is empty from air, it will go back till it reaches 0. So it should start by 0 in inspiration and go back to 0. And in expiration again, starts from 0 and go back to 0. The area under the curve in both is meaning the inspiratory tidal volume or expiratory tidal volume should be equal. Then the volume, this is, it will start by 0. Then at the time, the inspiration will stop, then expiration. So it is always positive. Very important understanding here, the area under the curve and the pressure time waveform. It is a simple way to calculate the map. So the area under the curve and the pressure time, it's equal to the map. Why map is important? So map is for the oxygenation. Whenever you want to improve your oxygenation, you need to increase the map. So either by the rise time, you make it more fast, or you increase the PIP, or you increase the eye time, increase the PEEP, or reduce the expiratory time. So by this way, you improve the map. And by this way, again, you improve the oxygenation. Now, from the flow waveform, as we discussed, it should start by 0. Then it reached the peak in inspiratory flow, come back to zero. And again, the peak expiratory flow, it should come back to zero before coming to the next cycle. So this is the inspiratory time, and this is the expiratory time. It helps us a lot. Actually, this is the most important waveform you need to always go and check it. And we will know why. Now the volume waveform, already we discussed it. Now the loops. There are two major loops. There is the pressure volume loop. So the relation between the two. And the what is the importance of the pressure volume loop? So the pressure is the relation, how much pressure you need to generate the volume. So it gives you this curve. So it starts initially, of course, either there is a trigger, then from the PEEP, it will go till increasing the pressure. So this pressure is not generating any volume, very little volume. Then at certain point, at the opening pressure, suddenly there will be shoot up in the tidal. So a little bit of pressure gives you more volume. So this is called the opening pressure. And this is really helpful later on to, let's say, to increase the PEEP. Maybe this patient really is having long time for the opening pressure. So I need to increase the PEEP to make it shorter. This is really helpful. And then it should go back in the expiration. Then suddenly there is the closing pressure here. Then where there will be loss of volume suddenly with less difference in the pressure. So this is, again, very important. This slope is the compliance, and how much distance between this graph and the compliance line is the resistance. Okay, again, the same. So this is the compliance, and this is the resistance. The other loop is the flow volume loop. It's like pulmonary function test, but in another way. So it gives you really a lot of information. So it will start by inspiration, then it will go in the negative side to expiration. Another way, actually, according to on the other side, yes. So the best, thank you, Dr. So the best ventilator is the ventilator which you know. Okay. Now we'll come to the interaction. So why those graphs or loops are important. How much time remaining? 10. Okay. So first we'll start with the time rise. So the time rise, so this is the time from the initiation till you reach your target. What I want is something in moderate rise. Why? Because if I make it very slow, there is no much time kept in the plateau. So by this way, you lose a lot when the patient is in the plateau time. So you lose a lot of some of the tidal volume. Okay, see, if you make it slow, you lose volume. If you make it fast, sharp rise time, you will have a pressure overshoot, and this can cause pressure injury to the lung. So I want it in this, it looks in this way. Yeah. Then again, so as we discussed, so if it is a slow rise time, you lose volume. See this, the area under the curve, how it look like and how it look like here. Okay. So if you slow rise time causes loss of volume, there is no enough time. You want to increase it. We discussed about the flow termination in the PSV. So we said if it is terminated very early, again you lose time, you lose volume. And if you make it very short, means it's very delayed at 10%. So what will happen? You are not enabling the expiratory valve to open. So the baby will expire on top of the closed valve. So this will show you as exhalation spike. So this means that you need to adjust your flow cycling. So fast termination causes loss of volume, and slow termination, there will be pressure overshoot. If the inspiratory flow not reaching zero, what are the causes of that? First of all, we said that the flow cycling in PSV, it should cut before it reaches zero. So you need to make sure, are we on PSV mode or not? From the beginning. If you are not in PSV mode, okay, there is a problem here. In the other modes, then I have to check what's going on. Why the inspiratory flow is not reaching zero? Is there leak or there's short eye time? So, and if there is leak, you will go to the volume waveform, you will see shouldering here. It's not reaching zero. So this means that there is leak. How to differentiate between both? Shouldering. So the pressure, the flow, it's continuing, is not reaching zero. So this is air leak. And the problem with this, that can cause, what leak can cause auto-triggering. What happens when there is leak from the ET tube? This air which is coming around the ET tube can generate sort of negative pressure. And the machine, if it is very low, if there is a very low sensitivity, very high sensitivity trigger, the machine can pick it up as a trigger. So that's why you need to be careful sometimes. Again, leak, so it should reach zero. If it is not reaching zero, cutting like this, so this is leak. Also here, if it should reach zero. If there is gap here, this is leak. So this is how it look like in different, this is just a summary. So if you are not reaching zero here, shouldering, and the loops looking like this, so this is leak around the ET tube. Now, if there is short eye time, usually, until proved otherwise, this is high resistance. There is secretions, you need to go and do suction. Sometimes, or initially in the preterm babies, when you give the surfactant, after improving of the compliance, then you need to increase the eye time at that time. So it is high compliance, improving RDS, or high resistance that needs suction. So again, short eye time. So just to give you an example, so if you have here the eye time is kept 0.3, see here, it's cutting, it's not reaching zero. How much tidal volume here is 9.9. So if I just adjust it and it reached zero, see how much I gain volume. Okay. Then the expiratory not reaching zero. So either it is long eye time, so I'm not giving time for the expiration, or there is high expiratory resistance, or there is high respiratory rate. So sometimes our juniors in the unit, there is high CO2, they will go and increase the rate. Maybe this is the problem. You need actually to reduce the rate to adjust the ventilation. So because here it is not reaching zero, it causes sort of air trapping, and this air trapping will cause increase in the CO2. Okay, so long eye time doesn't give you, sorry, I'll skip this one. So here, the air trapping. So when the expiratory time is not reaching zero, what will happen? There will be air trapping, and the air trapping will cause sort of auto peep. So the best way to adjust it, either to reduce the rate, increase the eye time, considering decreasing the peep. Again, here, how it look like in the loops. Now, if there is increase in the expiratory resistance, and this is usually due to some obstruction, bronchospasm, or secretion, this is how it look like. So there is sort of increase in the resistance in the loop. Again, how it look like in the flow volume loop. Yes? So this is when you give bronchodilator. So there is really very long, extended expiratory time. So when you give the bronchodilator, this is the way it looks like. It can give you a sign of improvement, that their baby is improved after the bronchodilator. Again, how it looked like in the loops. So this is before the bronchodilator with the bronchospasm, and this is after the relief. So if there is severe airway resistance and the alarm, please don't ignore the ventilation alarms. You have to go and check what's going on. So this means either the tube is kinked or there is migration of the AT tube, goes to the right bronchus. This is what's called, it will end up, if there is in both setups, so this is called hysteresis. Now, the nice thing when you put the baby on VG, on volume guarantee, so without using the volume guarantee, when you give the surfactant, the tidal volume improved because you keep the same pressure. And this is how it looked like. So when you put VG, so because the machine will always keep this tidal volume only given, so the required pressure will decrease. So this is sort of auto-weaning with the improvement of the compliance. So I'm giving the same tidal volume with reducing pressure. I'll skip that. So, and also in case of overdistension, this is, I can see it in the pressure volume loop, there will be peaking. So there is a parameter called the compliance C20 over C dynamic. If it is more than 1, this means that there is overdistension. Another important aspect, you get it from the graphics, is the air hunger. Is there increase in work of breath, which means that there is increased work of breath? Is there inadequate flow? The old ventilators, in the constant flow ventilators, you are setting the flow. So if this flow is not enough, the machine will not have that much flow to pressurize the air. There's no air to pressurize it. So there is no pressure reaching to the baby. So the baby will have increased work of breath. So the baby will have what we call it figure of 8. The baby is doing himself the work. So this is inadequate flow or inadequate rate. You put him on SIMV and without pressure support. So the baby himself is doing too much of efforts, and in between it's come the mandatory rate. So it is inadequate rate in SIMV mode or inadequate sensitivity. So the problem with the trigger, sometimes you set it very low sensitivity. So according to your machine, you need to understand your machine, how you set the sensitivity for the trigger. So if it is high sensitivity, fine. But if it is low sensitivity, sometimes the nurses will play with, they don't know what's going on. They play with it, or it's auto-setted. So the baby needs to generate high effort to trigger the ventilator. So again, there will be increased work of breath. So inadequate sensitivity. Now, another important point, and I think this is the last point before ending, is the auto-cycling. And this is very, very, very crucial. The auto-cycling or auto-triggering. What happens sometimes, there will be water condensation in the AT tube. This, we mentioned, this air, which is, this water which is moving in the tubings can generate sometimes some sort of negative suction, negative pressure, negative flow, and this can trigger the machine. So the excessive condensation ran out, or in case there is leak, we mentioned it before, or the baby is extubated. So the machine is just giving in the air. So if there is, again, don't ignore the machine alarms. So this is how it looked like. This is just, I took it from our patient. So there is water here. If it is video, you will see the water is running here and that. So the problem with this, why I brought this picture, what you can see in this picture that is wrong. And led, this is just a teaching point, led to increase in this rain out. What do you think? The trap is outside. It is nearby the ventilator. Yeah. So first of all, yes, the tube is hanged in this way. It should be straight. So the water will go in independent way. It will not lead. This is one point. And what's the other point? This is the most important, and we suffered a lot before we discovered. The heating wire should not be in the ventilator. In the incubator, sorry. Should not be in the incubator. If the heating wire in the incubator, already the incubator is heating, so what will happen? It will cause more heat and heat and heat. There will be more condensation of water. So the heating wire should be outside the incubator. So this is how it look like, auto trigger. And please, this is very serious. Why? Like, why? Why this is very serious? Why you should not allow this to happen? So if you have too much, the ventilator is giving unnecessary rate. What will happen? There will be washing of CO2. What it will lead to? طيب. The most serious, this is more serious than desaturation. You will lead to decrease in the cerebral blood flow. There will be cerebral anoxia. There will be decreased cerebral perfusion. I think I'll stop here. So this is the other type. It will be extubation. Thank you so much.